Hey, welcome to Brewski Tech. So this is another video in our series on building a fermentation chamber. So in this video, we're going to take the box and the electronic hardware that we built in previous videos, and we're going to basically tie it into Home Assistant. So this will finally allow the fermentation chamber to actually function, and you should be able to control it through your phone or any web browser. So let's get started. Okay, so to get started creating our new device, let's open a web browser and go to Home Assistant. Usually that'll just be a URL of homeassistant.local:8123. Now, if you don't have Home Assistant set up, there should be a link on the screen right now to show you a video that we have that we think is the easiest way to get started with Home Assistant and to get the ESPHome add-on installed into Home Assistant. So I'm just going to assume that you're already there, that you've watched that video or you've already set up Home Assistant. So let's go from here. So we're going to start off by going to the ESPHome builder. It should be in the left-hand pane there if you have it installed. Now, I already have two devices here. We can ignore these for this demonstration. And we're going to click on the big green New Device button that's in the lower right corner. Okay, so the first thing it's going to tell me here is that we're going to have to connect our new device via a USB cable to kind of initially upload the software to the device. So that's fine. After that, we can just use our Wi-Fi connection to upload any changes or updates we have. For now, we're just going to continue through that. We'll come back to actually connecting to it in a minute here. Now we're just going to give it a name. This name doesn't really matter. I like to kind of call devices, usually whatever they are or wherever they're located, and then usually with a number after them, 1, 2, 3, 4, 5, like that. So I'm just going to call ours Fermenter 2 because I already have my initial Fermenter 1 created here. You might want to do Fermenter 1 if this is your first one. Then the next thing we're going to do is choose a device. So this is basically the kind of brain of your device, which we talked about in the last video. So we're going to be using an ESP8266 based device. So I'm going to click on that. So let's go ahead and hit the skip button for now, because we don't want to just yet upload it to our device. We'll do that here in a minute. But first, what we want to do with our new device, it shows up here in the database or in the dashboard. It says it's offline, which makes sense. And we're going to hit edit. So this just opened a new page of text. Now, what we're going to do is we're going to basically get rid of this whole thing. So we're going to copy and paste the contents, like our example device configuration. And we can get that from one of the links down in the description. I'm going to copy and paste that right now. But keep in mind that whatever you see on the screen here as we talk things through, the kind of authoritative copy or definitive copy of this configuration is in the links in the description. So it'll either be in the GitHub repo or on the MakerHub site generally. Okay, so I've copied the contents of our example YAML file, our configuration file, and I'm just going to highlight this boilerplate that it set up for me, and I'm just going to paste in our configuration file. Okay. So the idea with these YAML files, if you've never used ESPHome before, is that they basically configure the device. So they specify like what sensors are connected to it, what motors or fans or whatever are connected to it, and which pins those are connected to on the NodeMCU device. So, and then once you've kind of set up this configuration, what happens is you'll hit install, and basically what that tells ESPHome to do is to look at your configuration, generate, it's actually C++ code behind the scenes. You don't really have to worry about any of that, but that's what it's doing. And then it compiles it with a compiler along with a whole bunch of other source files that are used to talk to a ton of different sensors and things that are supported by ESPHome. And then it compiles that down and then sends it, usually over Wi-Fi, to your device, and it starts running there. So the cool part about this is, number one, you don't have to write code if you don't want to. Two is that code for some of the logic, like we're going to have a thermostat device configured in this YAML, which we'll get into in a minute. That code is actually running on the device. So the cool thing is, if your Home Assistant box goes down for some reason, it doesn't really matter. The code is still going to be running on your NodeMCU device. It doesn't have to have Home Assistant there. Now you might need Home Assistant to control it, but it'll still continue to control the temperature in this case, because the code is running right there on the device, which is pretty cool. So let's go through the configuration file. Now the first thing you're going to see up here at the top is this ESPHome entry. So, and whenever you see anything on the screen, you can hover over it, and ESPHome will give you kind of a short description of it. So, but this section, this ESPHome section at the very top, is kind of like core or basic information about this particular YAML file or device. So we're going to give the device a name. Here I'm just calling it Fermenter 2. This can really be anything you want. Platform here, that's basically the processor that's going to be on the device. So, or the processor or CPU or whatever you want to call that, the thing that actually does the computing. And then this board entry, here we've got this set up as a NodeMCU version 2. This would be, even though it's using the same chip, there's a whole bunch of devices that you could use here. Now it's important to note, we're using a NodeMCU for this example, but there's a ton of devices that are supported by ESPHome. So you can use like Raspberry Pi Picos, you can use a lot of other 8266 devices, there's ESP32 devices. Anyways, there's a whole bunch of inexpensive devices here, and you can pretty much use them interchangeably. So if you have another device on hand, you can use that. But keep in mind that you will have to change the pin numbers, because all the pin numbers and pin labels are different for every device. So if you change the board, make sure that you update all of the pins with the way you have it wired. Okay, moving on. So a lot of this stuff I'm not going to go over in great detail. You can look in the ESPHome documentation if you're really curious about how some of this other stuff works. But it's worth focusing on the Wi-Fi section. So this is basically this specifies the SSID and the password for your Wi-Fi network that it should connect to. This is configured to use a secret called Wi-Fi _SSID for your SSID, and likewise a secret called Wi-Fi password. I'm going to show you the secret editor here in just a second, but first let's talk about this. So this is basically exactly what it says. It's a fallback hotspot, and basically if your device can't connect to your Wi-Fi network for any particular reason, it will create its own hotspot that you can connect to so that you could reconfigure it. So this is just setting up what that fallback hotspot will be called, and then also there's a backup Wi-Fi password that's in the secret editor. So let's actually jump out of this. So I'm going to hit save in the upper right corner and then hit the X button to just temporarily exit out of this YAML file. And then to edit our secrets, we're going to click on this button up here called Secrets. Now, I'm not going to show you mine because well, it's secret. But basically you can just enter as many secrets as you want. Each line in that file is going to contain basically like a variable name. Like you saw, I used Wi-Fi underscore SSID. And then you give it a name, and then colon and space, and then the actual value for it, or the secret in quotes. So you can kind of see on screen there what it should look like. And you can enter as many secrets as you want in there. Anything that you want to keep kind of that's the same for all your devices, or is something that is a secret, like your Wi-Fi password. It's appropriate to put that in the secrets file. Okay, with that said, let's jump back into the YAML file. Okay, so for this next part, I'm going to scroll down a little bit so you can see, and we're going to talk about the I/O configuration, or input-output configuration. So this is basically just telling ESPHome how you have this device wired up, like what's connected to what pins. So if you Google for your device, like for instance our NodeMCU, if you just Google NodeMCU pinout, you'll see plenty of pictures that show the pinout diagram. And also on our device, if you look really closely, the pin numbers are actually labeled on the device itself, which is pretty cool. What we're going to do is, for this first one, I'm just configuring, there's an LED on, or a little light on the NodeMCU. So I'm going to go ahead and set that up so ESPHome knows how to use that. So the first thing we're going to do is create a platform GPIO. So that stands for General Purpose Input Output. And then we're going to give it a name. Again, name doesn't matter. It's just whatever makes sense to you. I called it Fermenter LED. In this case, the logic is inverted. That's true. So basically that means when there's a high voltage on that pin, the LED will be off. And when there's a low voltage, the LED will be on. So it's an inverted logic, basically what that's saying. And then the last and most important thing is the pin. So we're going to say pin colon D0, because that's what's actually connected to the LED on the NodeMCU. Okay, and then next we're going to create another GPIO pin, same exact format. This one, because we're going to use it later in our thermostat configuration, we're going to give this one an ID. So again, this can be whatever you want. Just make sure it's not in quotes. And I'm calling it fan power, because this is going to be the pin that's going to turn on power or control power to our fan motor. And then I give it a name, again, Fermenter fan power. Again, that's what made sense to me. And then the pin that's connected to, in this case, that's going to be the pin that is wired up to one side of that relay board that we talked about in the last video. So pin D5 in my case is going to be the one that controls that relay, turns it on and off. Okay, so that's basically both of our outputs from this device. And notice that they were all inside of this switch block, which is basically ESPHome's way of saying that it's a GPIO switch. So it's got an on or off state. Okay. So now for the next thing, we're going to set up our temperature sensor. So that's what we're going to use to sense what the temperature is inside of the fermenter. So in this case, we're using a one-wire sensor. And in order to talk to that one-wire sensor, we need to first set up a one-wire bus. So that's created with this one-wire component. It's just one underscore wire. And then again, we're going to tell it what GPIO pin to use for this one-wire bus to communicate to the sensor. So again, we're creating a GPIO kind of component, and we're going to tell it what pin that's going to use. And in this case, the pin that's connected to our temperature sensor data line is pin D4. Okay. So now we have a one-wire bus that's ready to go. but ESPHome doesn't yet know what is connected on that one wire bus. So this next block, this sensor block, is going to connect that together. So here we're again going to give it a name, fermenter temperature. We're also going to give it an ID because, again, we're going to use this later down in our thermostat component. So this one I just called fermenter_temp. We'll have to remember that for later. And then the platform, this basically says what is the sensor that's connected on the one wire bus. In this case, it's a Dallas temperature sensor. Doesn't mean much, but that just is, that's Dallas Semiconductor is the maker of those temperature sensors, or at least they were. And so we're going to tell it, yes, it is a Dallas type temperature sensor. And then we're also going to add this update interval field, and we're going to tell it to update the temperature every 5 seconds. So basically go out and read that temperature sensor every 5 seconds. The next block here is all commented out. That's what the kind of pound character does, is it comments this out. So this actually won't do anything. But what I was trying to do here is our fan device actually has a pulse counter line on it. So you should, in theory, you could read the fan RPM. But I couldn't get that working on my particular fan, so I just commented it out. But if you want to play with that with the fan you're using, feel free. I put it there in the comments so you can use it yourself. Okay, so that's all of the sensors we're going to have for this device. For now, let's focus on this climate object. So basically, I created a climate object. This is the thing that's going to basically read, it's going to have the control logic. So it's going to read that temperature sensor, and then it's going to either turn on or turn off the fan based on the temperature. This is a climate type object. That's how ESPHome refers to thermostats. And then again, we're going to give it a name. I'm just calling it fermenter thermostat. Again, an ID, fermenter underscore thermostat. And then some of these I'm just going to go through quickly. This is kind of, a lot of this is just kind of boilerplate. So again, you can go to the ESPHome documentation and look up the climate object and learn all about all the possible parameters. And there are a ton of them for the thermostat. But I'm going to very quickly go over the ones I was using. For visual, this is just setting up the kind of control that you'll see on the Home Assistant dashboard. So you're kind of giving it a minimum temperature and a maximum temperature, and the temperature step, like how much it should move, like when you kind of turn the dial on the dashboard. So that's what these are for. The sensor, this is an important thing. This tells it what to use for the temperature sensor. So remember, up above, we gave our one-wire temperature sensor an ID of fermenter temp. So this is the place that we fill that in. So that's telling this thermostat object, hey, when you read the temperature, go read it from that one-wire temperature sensor. This is setting up some of the defaults. I believe also all these numbers, when we're talking about temperatures like min, max temperature, and default target temperature, I believe these are all in Celsius. So that's why, if you're curious why they seem low, that's why. Also, cool deadband, cool overrun, min cooling time, all of these are pretty short. The reason is that we're just turning a fan on and off. If you were using this to control something like a refrigerator compressor, you probably would want to set much larger values for these. Like you might want to put 10 minutes for the cooling off time, but that's kind of outside of the scope of this device. For us, we can have these all be pretty short values because it's just turning a fan on and off. It's not going to hurt anything if you turn it off very quickly. Okay, then the next thing I have here is a cool action. So basically, when the thermostat object sees that the temperature read from the temperature sensor is too high, it will run this cool action. And in this case, what we're going to do is we're going to turn on our fan power. So basically, that's going to turn on that GPIO. that we set up above that's connected to our relay module, which will then turn on power to our fan. So basically that's what this says is cool action. When you need to cool, turn on the fan power pin. And then likewise, idle action. So when you don't need to have the cooling turned on, you want to turn off the fan power switch. Now note, you can have more than one action here. In our case, we don't need it because we just need to turn on and off that one GPIO pin. But if you had another pin that was connected to an LED that you wanted to turn on whenever it was cooling or cooling was on, you could add another statement right here that would turn on that LED. So it's a very powerful setup here. But this is basically all the logic we need to have this device control our fan automatically. That's it. The last thing we're going to talk about here is an optional device, which is that LCD that we again talked about in the last video. So if you don't want to have an LCD connected or liquid crystal display connected to your device, that's fine. You can skip this part. If you do, let's talk this through. So you notice above I said I was going to come back to this. So our LCD device actually communicates on a bus similar to that one wire bus, but a little bit different, called I2C. So we need to basically tell this we need to set up this I2C bus so that we can use it later to communicate to our LCD. So we're basically going to tell it what pins are connected to the SCL and to the SDA lines of our LCD module. In this case, it's D2 and D1. And then down below, that's where we actually set up our display. So it knows that it should use the I2C bus to talk to this LCD. And we're going to put this in a block called display. And the platform, which again is just kind of telling it what device is actually connected, is this LCD PCF 8574. So basically that's the little chip that communicates over the I2C bus back and forth from the NodeMCU to the LCD. And then we're going to tell it dimensions. So in our case, I've connected a 16 character by 2 line LCD. So if you get a bigger one that's like 16 characters by 4 lines or whatever, you'd want to change this dimensions field. And then also here's this address field is basically saying what I2C address this device will communicate on. And I believe by default this device communicates on this address. So I would just probably stick with that unless you have any issues. Okay, now this last part is kind of the magic part. So I've said that you didn't have to write code, and I was mostly correct. But actually, this is a little snippet. This is 2 lines of C++ code. So basically, what this is saying here is, hey, we want to print this string, Ken's Fermenter, to character 0, line 0. So basically the first line of the character LCD. That's what this line here means. Okay? And then the second line here, so this is going to print to character 0, line 1. So the second line of the character LCD. And it's going to print out temp, and I'll get to what all this means here in just a second, because it looks a little weird. But basically what I'm trying to do here is I'm trying to print the current temperature, and then a slash character, and then the target temperature. And I also want to print it out in Fahrenheit, just because I'm more used to Fahrenheit. Okay, so now what are these percent? I have a %.1f right here. So what that is that's a format code. So that's basically saying I'm going to supply a number, and we want to print that number as a floating point number with 1 digit after the decimal point. That's what the 0.1 means. So the lowercase f means a floating point value, and then the 0.1, the 0.1, oops, I just moved that around, didn't I? Okay. The 0.1 there says print 1 digit after the decimal point. Okay? And I'm using the exact same format code here. You'll see this other % block. Okay. So that tells it how I want to print out the numbers that are displayed there. And then the next part is these are all comma separated values. So the next comma separated section here, what I'm doing is I'm saying ID fermenter temp. Now remember, that's the ID of our temperature sensor. So I'm basically saying the temperature sensor current state, which just means the current temperature of that temperature sensor. And then I'm multiplying by 9, dividing by 5, and adding 32. That's just to convert it from Celsius to Fahrenheit. Okay, and then there's a comma, and so then we have, so this value is going to be calculated on the device and printed out in place of this %.1f value here, the first one. Okay, then the second kind of comma delimited one is going to calculate the target temperature of the thermostat. So we created an ID for our thermostat as well. So we're going to grab that thermostat, and then we're going to get the target temperature that's currently configured for that. And then again, we're going to convert that to Fahrenheit. And then that will be printed out in place of this %.1f here. So that's going to be computed on the device and printed to the LCD. Okay, so that kind of completes our walkthrough of the YAML file. Okay, so now it's magic time. We're going to actually compile this thing and upload it to the NodeMCU. Basically, the next thing we need to do is connect the NodeMCU to a USB cable. So that's going to allow us to do the initial software upload to the device. After we do this initial upload, you won't have to connect it to your computer anymore. We should be able to update the code or the configuration via Wi-Fi. So on screen here, I'm just showing the NodeMCU. It's perfectly fine to connect a USB cable while the NodeMCU is in the circuit, like while it's connected to the temperature sensor and the fan and all that good stuff. Here I'm just showing a bare NodeMCU. But you don't have to pull your NodeMCU out just to upload the software here. You can hook it up. But if it is in the circuit, like in the final circuit, you should probably check the power rails to make sure they're not shorted before you plug it in, just to be on the safe side. If you're not sure how to do that, there should be a link on the screen now that shows you, we have a little video on how to use a multimeter to do that. Let's get the USB cable hooked up to the NodeMCU. If you're like me, you probably have a dozen USB cables lying around in some drawer someplace. So just pull one of those out. For this device, you want a micro USB, but just find the USB cable that will plug into the USB port on the NodeMCU. One thing to keep in mind is sometimes you'll get USB cables that are for charging only. Like basically it only has the power and ground lines hooked up in the USB cable. You need a USB cable that actually has the data lines populated. So if this process doesn't work at first, maybe try a different USB cable. They're cheap. It's easy just to try it again with a different cable. Let's go ahead and save it one last time, and then we're going to hit the install button. All right, so the first thing it's going to do is ask you how to connect to the device. We're going to say plug into this computer. So click on that. Let's see, here it's saying install via the browser. Yes, that's what we want to do. So it's now saying it's preparing the download. So basically this is telling me that I'm not connecting to my Home Assistant instance over HTTPS, meaning it's insecure. It says it's not going to let me download directly from this browser, but that's okay. Basically what it's doing in the background here is it's compiling our configuration file and generating C code and then compiling that. So this is going to take a few minutes. For subsequent updates to this configuration file, it'll be much faster, but this could take 10, 15 minutes to get done. Subsequent updates will take like seconds. So just be patient, let the little spinning icon complete. Okay, now it's finished. So let's click on this download project link. And what'll happen is we'll get in this case, fermenter2.bin. My browser is flagging this as an insecure download, so I have to click a little keep button. You may not be able to see that in the recording, but that's just going to download a file. It's like 0.5 MB. It's a pretty small file, so that'll be in your downloads folder. Okay, and so once you've downloaded that binary file, we can click on this Open ESPHome Web link. So that link sends you to this web-based flasher tool. And so the idea behind this is you can use the binary file that we downloaded in the last step and this web-based tool to upload the initial code to the NodeMCU. Now, I had trouble using this tool, so what I'm going to show you instead is how to use even another way to upload this. If this web-based tool works for you, then that's great. But here's a different method. So there's a tool called the ESPHome Flasher, and we can go right to, this should be the first result. This is just a tool created by the ESPHome folks. Get the latest version. So over here on the releases side, we can just click on whatever the latest version is of that. And then you can download whatever you want for the right OS or for the operating system that you're using. In this case, I'm using 64-bit Windows, so we'll download the Flasher utility for that operating system. And then just go ahead and launch that tool as soon as it's downloaded. Okay, so now once that is launched, you should see a screen kind of like this. Okay, so the first thing we're going to do is before we do anything in this tool, we're going to hold down the flash button on our NodeMCU device, and then we're going to plug it in as we're holding down that button. That should put the NodeMCU into kind of programming mode or flash mode. You can keep holding that button down for a few seconds. Let's go ahead, and now we're going to pull down, we're going to try and find the serial port that just got created when we plugged in the NodeMCU. So let's hit the refresh button, and there we go, COM3. That should be our NodeMCU device. Okay, then the firmware, we're going to hit the browse button, and you may not be able to see it on the screen, but it opened a little file dialog, and we're just going to select the .bin file that we downloaded in the previous step. So select that, and then you should see, yep, fermenter2.bin. So that's that. And then the next thing is we're just going to hit the flash ESP button. Okay. So, and it's connected to the device, and it's now erasing the flash. So it should just take a few minutes. Now it's uploading the new code. Oh, there we go. Looks like it successfully uploaded it. And it's connecting to my Wi-Fi network. Great. Okay. So at this point, we successfully uploaded our firmware. So we should be able to go back to ESPHome and we should be able to see the device. Okay, so now we're back in ESPHome. And you can see that Fermenter 2 that we just created is showing as online now. So that's a great sign. That means it connected to the Wi-Fi and it's working correctly. Now, I do want to mention at this point that if you have any trouble through this process, once you have the initial ESPHome or the initial firmware uploaded to your NodeMCU, you can use the logging feature of ESPHome to basically see more information on what's going on with your NodeMCU. So this is great if you are having any issues, like maybe it's not reading the temperature sensor correctly, or it's not able to control the fan or whatever. You can actually click this logs button, and what it'll do is it will connect over Wi-Fi to your device. And you can just see basically what's going on with the device. So it'll tell you if it's reading the temperature sensor, if it's connecting to your Wi-Fi correctly, if it's anything that's going wrong. So I actually don't have this NodeMCU currently hooked up to the hardware that we set up in the last video. So you can see here that it's saying, hey, the LCD display failed to initialize. Now, I'm expecting that because I don't have it hooked up to anything, but that's just an example of the sort of additional information you can get in these log files. I encourage you, just go ahead and click on that log if you're having any issues with the hardware not connecting, and it'll usually tell you exactly what the issue is. And 9 times out of 10, it's going to be that something isn't connected correctly. So maybe it's trying to connect using the wrong pen to some device or whatever. But these log files are fantastic for debugging any sort of issues that you might have with your device. So always keep that in mind. So another thing that you'll want to do here is, now that this is showing up as online and the firmware is clearly installed, we can go down to Settings and then go to Devices and Services. Click on that and you'll notice that it has discovered a new device. So it's showing the Fermenter 2 as newly discovered. So basically, we'll want to click that Add button and walk through the process there to add this device, and then that will make all of our thermostat and that kind of thing show up on our dashboards in Home Assistant. And basically, at that point, it's usable. I'm not going to click on this now because this was just kind of an example device for me, but let's jump back over to the dashboard, and here, basically, this will pop up on your dashboard after you've added the device. You'll have a new kind of thermostat device, and this is what you'll use to control your brand new Fermenter. And you can see the controls are pretty intuitive. It's showing you here in the thermostat. Right now it's turned off, but we can turn it on by just hitting the cool button. And then you can adjust the set temperature using the plus and minus buttons, and you'll see that changes here. And then the current temperature that it's at is displayed here right below the set point. And so you can also, this little state here will show you kind of what status it's in. So basically whether it's trying to cool or whether it's just idle. So that's it. It's pretty simple to use. And this will also show up on your in your Home Assistant app on your phone. It'll look the same. This is basically our Fermenter in action. This is what we did all the work for. I'm going to turn that back off now. Thanks for watching the video, and I hope you've gotten your Fermenter working now after doing the steps in this video. We will have a follow-up video that talks about doing some more advanced automation in Home Assistant using this device, so stay tuned for that. But for now, if you have any comments or questions, leave those down below the video, and we'll try to get to those and respond. And otherwise, thanks for watching.